This is a 5 marks question, very frequently asked question. Now let us consider what is it, where does it take place, what are the steps involved, what are the factors affecting the spermatogenesis, what is the applied aspect. So that means I have divided 1 marks each for these questions. So what is spermatogenesis, where does it take place, what are the steps involved, and what are the factors influencing, and applied aspect. Let us see how we can do it. It is a process of formation of the spermatozoa in the seminiferous tubules from the gonadal cells. I am not telling seminiferous tubules of the testis because the seminiferous tubules are present only in the testis. There is no need to tell that. So it is the formation of the spermatozoa from the spermatogonial cells in the testis. It involves mitotic and meiotic division. It involves differentiation as well. That is spermatogenesis. What are the steps involved in the spermatogenesis? Here I have drawn one spermatogonial cell. From the spermatogonial cell, there will be a division. This is the spermatocyte, one primary spermatocyte. Spermatogonial cell to primary spermatocytes, there will be nearly 8 mitotic divisions. 8 mitotic divisions. And after this primary spermatocyte, what happens? So this divides meiotically. The first stage of the meiosis, the first meiotic stage. So that makes the two cells with a haploid chromosomes, 22X or 22Y chromosomes. This is a secondary spermatocyte. Here you have a 2N chromosomes, and here SC2 is a secondary spermatocyte. You have a haploid number of chromosomes there, and then you have the second division that forms the spermatid. This is a spermatid. That means after the second meiotic division, they form this spermatid. Again, the N is the same as before, the 22X or 22Y, whatever. So 22X, that will become a female baby, 22Y, that becomes a male baby. So now from the spermatid, it will be differentiated. Now up to this point, there is a division. 8 mitotic divisions here, 2 meiotic divisions. So in all, we have about the 512 from one spermatogonial cell. We get around 512 spermatozoa or spermatids. So you can calculate. That is why I mentioned 8 mitotic divisions and 2 here. That comes to 250 is 512. And the exact total duration from here to here is about 74 days. 74 days is the duration to form. And even when in the seminiferous tubules, when these spermatozoa are formed, they may not be fertile. So that means they have to go into the epididymis, and then there will be a maturation in the epididymis. So that means the spermatozoa are formed here, then they are moved to the epididymis, and in the epididymis they stay there for some more time. They get matured because the spermatozoa of the seminiferous tubules are fatter, and they are having more water. So as they reach in the one which is leaving the epididymis, they are becoming thinner and removed of the extra water they had. So that is the spermatogenesis. Okay, this is one component. So then comes this is the same thing. I have taken it from a book there. So we have the testis there. These are the seminiferous tubules, and this is the one sector of the seminiferous tubule. This is seminiferous tubule transverse section, one sector of the seminiferous tubules, and you have the Sertoli cell there. And the Sertoli cell will have these gonial cells associated. Almost they are embedded in the, they are encroached by the Sertoli cells, or embraced by the Sertoli cells. This is embracement. You can just see that these projections, the cytoplasmic projections of the Sertoli cells, and they are holding, and even these spermatozoa are there within the Sertoli cells. And this is one of the matured spermatozoa where a chromosome is there, and then we have a mitochondria there, and this nucleus and the flagella. So this is the thing, and you have the spermatogonia, primary spermatocyte, the secondary spermatocyte, the spermatid, and spermatozoa. Now, the differentiation from the spermatid to spermatozoa is known as a spermiation. The process of forming the spermatozoa from the spermatogonia is a spermatogenesis. And the differentiation from the spermatid to spermatozoa is known as a spermiation. It is a process of maturation and differentiation of the spermatid to spermatozoa. The stages from spermatogonia to spermatid appear to be androgen independent. Spermatogonia to spermatid appears to be androgen independent. However, the maturation of the spermatid to spermatozoa depends the androgen acting on the Sertoli cells, because these stages are driven by the FSH, but then subsequent maturation, these maturation, they require after spermatid, they require the androgen there within this lumen. You have the androgen binding protein there, and androgen levels are very high in the seminiferous tubules. Now move on. So this is how it looks like. It is taken from Genong. You can just see that this is basal lamina, and these are fibroblasts. And what is happening? These are interstitial cells. These are leading cells. So now you have these spermatogonial cells, spermatocyte, primary spermatocyte, secondary spermatocyte, and the spermatid, and these are the spermatozoa. So this is in the late stages, and you can just see that. So you have various divisions happening, and this one is a Sertoli cells. You can have Sertoli cells they have the blood testis barrier. They do not allow anything to enter inside. So here is the lumen. What are the factors which influence the spermatogenesis? One, hormonal factors. What are the hormones? Testosterone is required for spermatid to the spermatozoa differentiation. Then LH is necessary for the secretion of the testosterone from the leading cell. FSH is necessary for the activation of spermatogonial cells, at the same time for the nourishment which it receives from the Sertoli cell. Estrogen is also necessary to increase the activity. Growth hormone, thyroid hormone, and hypothalamo-pituitary gonadal axis. All these things are required for normal spermatogenesis. I mentioned here testosterone, LH, FSH, estrogen, thyroid, growth hormone. Then stress. Then if there is a stress, that would decrease that would alter this hypothalamo-gonadal axis. So that means that will decrease the spermatogenesis. The nutritional deficiency, so that would alter the spermatogenesis, especially the vitamins B, A, and E. B, A, and E, and even the C vitamin is necessary for its sperm decomposition. Ascorbic acid is the semen is rich in ascorbic acid, and these vitamins are very much required. That means B, E, and A, and C also. So then a lot of minerals, zinc and other minerals, they will influence the spermatogenesis. Then the temperature of the testis is important. It is kept at 32 degrees centigrade. So that is why the testis is thrown out of the body, and it is in the scrotal sac. It's not, though it is an intra pelvic organ, and but during the growth of this thing, and it will come out through the inguinal canal and occupies the scrotal sac. So now in the event undescended testis, what is called a cryptorganism, undescended testis, what happens? Testis remains in the abdominal cavity. In the abdominal cavity, the temperature is 37.4 degrees Celsius, and that is not helpful for the spermatogenesis. So the spermatogenesis requires a lower temperature, 32 degrees. So for that reason, scrotum provides the detrusor muscle provides that the temperature regulation. Or in case of the varicocele, where there is a increased blood supply to the scrotum because of the varicocele, so you have this the spermatogenesis decreasing, and you may find low sperm count. Or a person exposed to hot environment or taking a hot bath, the very hot this thing is not good for the spermatogenesis. And there are some occupations wherein they are sitting in front of the furnace for long, and they may have these the genitalia exposed to the temperatures. So that means they will suffer from the sperm count, decreased sperm count. And seasonally, it is known that in the winter, the spermatogenesis is increased. The infections like mumps, especially the mumps, that would attack the glands, mumps, and even the plague. Nowadays, the plague is not there. So the plague and the mumps, they will attack the gland, and they will destroy the seminiferous tubules. So they become infertile. So that means previously, at one stage, somewhere in the late 1880 or something like that, or early 19th century. So you have those plague epidemics coming up, and these plague epidemics have made many men infertile or sterile. So that means mumps and plague, they attack the glands. And other systemic diseases affect the spermatogenesis or decrease the spermatogenesis. The toxic chemicals like the heavy metals, the cadmium and lead, they will be toxic to the spermatogenesis. That means they decrease. Dioxin, these are chemicals present in the pesticides, and the chemicals present in the plastic, that is the bisphenol A and other chemicals, they will all and even the pesticides, they will decrease the spermatogenesis. The excessive alcohol, that will decrease the spermatogenesis. And even consumption of the anabolic steroids, because some of these athletes, they will consume the anabolic steroids. What happens in the anabolic steroids, it will they have the testosterone like activity. Now testosterone in turn have a negative feedback activity on the FSH or in the pituitary. So that means FSH is decreased. If FSH is decreased, spermatogenesis is decreased, because for the beginning or the starting of the spermatogenesis, it is FSH required. So these are the various factors affect the spermatogenesis. Hope that makes the points for your spermatogenesis.